Welcome to the spoken tutorial on increment and decrement operators in C and C++. In this tutorial, we will learn about increment and decrement operators. Plus, example, A++, which is a postfix increment operator, ++A, which is a prefix increment operator, minus. A minus minus is a postfix decrement operator, minus A is a prefix decrement operator. We will also learn about typecasting. To record this tutorial, I am using Ubuntu 11.10 as the operating system, GCC and G++ compiler version 4.6.1 in Ubuntu. The ++ operator increases the existing value of the operand by 1. A++ and ++A are equivalent to A is equal to A plus 1. The minus operator decreases the existing value of the operand by 1. A minus and minus A are equivalent to A is equal to A minus 1. I will now demonstrate the use of increment and decrement operators with the help of a C program. I have already made the program, so I'll explain the code. Here we have the code for increment and decrement operators in C. Here I have taken an integer variable a that holds the value 1. This way we will be able to observe the changes in the value of a. It will thus give us a better idea about the working of the operators. Let's see how the postfix increment operator works. The output of this printf statement is 1. The value won't change. This is because the postfix operation occurs after the operand is evaluated. If an operation is performed on A++, it is performed on the current value of A. After that, the value of A is incremented. Now, if we see the value of A here, it has been incremented by 1. We again initialize A to 1 so as to reflect on the changes. We now come to the prefix increment operators. This printf statement prints 2 on the screen. This is because a prefix operation occurs before the operand is evaluated. So the value of A is first incremented by 1 and then it is printed. We again print A's value to see that there are no further changes. Now let's check by executing this code. I will comment out the following lines. Type /**/. Click on save. I have saved my file as incrdecr.c. Open the terminal window by pressing Ctrl, Alt and T keys simultaneously. To compile, type the following on the terminal. gcc space incrdecr.c space -o space incr. Press enter. To execute the code, type //incr. Press enter. The output is displayed on the screen. This is the output when you print A++. This is the output when you print ++A. We can see that the result is as discussed before. Now coming back to the rest of the program, I will now explain the postfix and prefix decrement operators. Remove the multi-line comments from here and here. We now again assign the value of 1 to A. This printf statement outputs the value of 1 as explained previously. A's value will be decremented after A minus is evaluated, as it's a postfix expression. The next statement prints A's value as 0. A's value has now been decremented by 1. We now have the prefix decrement operator. Output of this printf statement would be 0, as it is a prefix operation. The prefix operation occurs before the operand is evaluated. This printf statement's output is 0. No further changes have been made to A's value. Type return 0 and close the ending curly bracket. Click on Save. Switch back to the terminal. To compile, type the following on the terminal: gcc space incrdecr.c space -o space incr. Press enter. To execute, type /incr. Press enter. This is the output when you print a minus minus. This is the output when you print minus minus a. So now we see how the increment and decrement operators work. If I want to write the same program in C++, I can make a few changes to the above C code. Let me go back to the editor. Here is a C++ file with the necessary code. Notice that the header is different from the C file header. We have the using namespace statement also. Also note that the output statement in C++ is cout. So apart from these differences, the two codes are very similar. Save the file. The file is saved with an extension .cpp. Let's compile the code. Open the terminal and type g++ space incrdecr.cpp space -o space incr. Press enter. To execute, type /incr. Press enter. The output is displayed on the screen. So we see the output is identical to the C program. We now have the concept of typecasting. It is implemented the same way in both C and C++. Typecasting is used to make a variable of one type act like another type. Typecasting is done by enclosing the data type you want within parentheses. This cast is put in front of the variable you want to cast. This typecast is valid for one single operation only. Now A will behave as a float variable for a single operation. Here is an example that I've already created. I shall now explain the code. We first declare variables A and B as integer and C as float. A is assigned the value of 5. D is assigned the value of 2. We will perform operations on A and B. We divide A by B. The result of division is stored in C. We have used %.2f to denote a precision of 2 decimal places. The result displayed will be 2.00 against the expected result of 2.50. The fractional part has been truncated as both the operands A and B are integers. To perform real division, one of the operands will have to be typecast to float. Here we are typecasting A to float. C now holds the value of real division. Now the result of real division is displayed. The answer is 2.50 as expected. Type return 0 and close the ending curly bracket. Click on save. Save the file with .c extension. I have saved my file as typecast.c. Open the terminal. To compile, type gcc space typecast.c space -o space type. Press enter. To execute, type ./type. Press enter. The output is displayed on the screen. Looking at the two values, we see the effects of typecasting. We will summarize the tutorial now. In this tutorial, we learned how to use the increment and decrement operators. We learned about the forms, postfix and prefix. Also, we learned about typecasting and how it is used. As an assignment, write a program to solve the following expression: A divided by B plus C divided by D. The values of A, B, C and D are taken as input from the user. Use typecasting to perform real division. Watch the video available at the following link. It summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials, gives certificates to those who pass an online test. For more details, please write to contact@spoken-tutorial.org. Spoken Tutorial project is a part of the Talk to a Teacher project. It is supported by the National Mission on Education through ICT, MHRD, Government of India. More information on this mission is available at spoken-tutorial.org/NMEICT-intro. This is Ritvik Joshi from IIT Bombay. Thank you for joining.